Hi guys, Nevada Virtual Academy, you are moving on, radicals with variables. Today we covered in class this, right? And the basics are, the basic fact here is that the square root of a non-negative number that is squared is the original number, right? I hope it makes sense. We talked about in class. Let's find and let's solve a few problems related to this topic. Alright everyone, let's do problem number 1 first, right? I have square root of x to the 4 times y to the 10. How can we simplify that? Well, first of all, I can rewrite this square of a product as the product of the squares, right? I have square root of x to the 4 times square root of y to the 10th, right? What is that? Well, do remember that the square root is actually, raising your number to the power of 1/2. So basically you have x to the 4th, everything to the power of 1/2, times y to the 10th, everything to the power of 1/2. Now, I hope you remember one of the properties that said if you have a number a to the power of n, and you raise it to the power of m, you get a to the power of n times m, right? This is the power of powers property. Knowing that, if I'm going back to my problem, then I realize that, x to the 4th, everything to the 1/2 will be x to the 4 times 1/2. 4 times 1/2 equals 2, right? So the x squared times y to the power of 10, everything to the power of 1/2 will be 10 times 1/2, and that gives you 5, right? And this is the simplification of problem number 1. X squared, y to the 5th. Let's do number 7. Okay, number 7, as in the previous one, I will break this square root of a product into the product of the square root. So it'll be square root 15, right? 4 times square root 15 times square root of x to the 14 times square root of y to the 11 times square root of z squared. Let's go with one at a time. It will be 4 times square root 50 is actually square root of 2 times 25, or 25 times 2, right? Square root of x to the 14 is x to the power of 14 over 2, okay, which equals x to the 7th. And they're telling us that all variables are non-negative numbers, so we don't have to worry anymore of anything that will be related to your x being positive or negative, right? Okay, so this would be times x to the 7th, right, times y to the 11. If I have y to the power of 11, right, square root of that would be the square root, it would basically be y to the power of what, 11 over 2, which equals y to the power of what, 2 goes in 11, change that power into a mixed number, will be 5 and 1/2, which I can write it as y to the 5th, right, times y to the 1/2. The y to the 1/2 is actually square root of y. So now I have y to the 5th times square root y. Do you guys understand what I did here? Okay, that y to the power of 1/2 is actually square root y, okay, times square root of z squared, that will be z. Now moving on, simplifying, right, you have square root of 2 times 25. This is the same as square root 2 times square root 25, which equals square root 2 times 5, or 5 times square root 2. Okay, so this will be 4 times square root of 2 times 25 is 5 square root 2, so it'll be times 5 square root 2 times x to the 7 times y to the 5th times square root y times z. And now I will rearrange everything. First thing, the numbers and variables with no square root, right? 4 times 5 is 20 times x to the 7th times y to the 5th times z times square root of y. And we are done. Make sense? How about number 18 first, right? This equals, do you guys remember the property? If you have square root of a over b, well, first of all, b should be different than 0, right? This is the same as the quotient of your square root. So the square root a over square root b. Applying that here gives me square root x over square root 13. Now, because we cannot have square roots in our denominators, we need to rationalize that square root 13, and we're doing that by multiplying it by itself, right? Because you're multiplying the bottom, you're multiplying the top by the same number. Basically, you're multiplying everything by 1, because square root 13 over square root 13 is just 1, and this gives you square root of x times 13 over square root 13 times square root 13 will be just 13, or we can rewrite it as square root of 13x over 13. Okay, and this is all we can do about 18. How about number 21? I should change the color. Let's try a blue, maybe a thicker line. Alright, zoom in a little bit. Number 21, right? Number 21. Let's do thick now. Equals. Well, the top stays 5a. The bottom, square root of 84. Let's see what what factors 84 has, and you have a few ways, right? You can look for the prime factors. 84 divided by 2 will be what? 2 goes in 8. 4 times 2 goes in 4. 2 times 2 goes in 42. How many times? 21 times. 3 goes in 21 7 times, and we're done, right? Looks like my 84 is actually 2 times 2 times 3 times 7. Basically, I can rewrite 84 as 4 times 21, right? Because 4 is a perfect square. The whole thing now becomes 5a over square root 4. Let's go one step at a time. Square root 4 times square root 21. And this will equal 5a over 2 square root 21. Now I will rationalize this by multiplying top and bottom by square root of 21 times square root of 21, right? The whole thing equals now 5a square root of 21 over 2 times square root 21 times square root 21 will be 21. I have 2 times 21, which gives me 42. And I am done. Okay, 42 and 5 don't have any common factor, and that's the end of it for this problem. Make sense? Alright, the next set of the problem says evaluate each expression for the given values, provide answers in simplified radical form and approximate irrational answers to the nearest 100, right? How about number 22? Part A. X equals 10, which gives you square root of what? 10 plus 7, right? Which is square root of 17. Now that's a prime number. We cannot do anything to it. The next step will be to approximate the value of this. You guys remember yesterday we talked about the Babylonian method. Obviously your 17 is between 16 and 25. We're taking the closest, square roots to 17, one smaller, one greater, right? If you take the square root of both, all three sides, actually you got 4 less than square root of 17 less than square root of 25, which is 5, right? So basically square root of 17 will be most likely 4.1, and I believe we did a problem like this in class. But anyway, I'm assuming that my first root r1 will be 4.1, right? To find a better approximation, I will say my second root will be r1 plus 17 divided by R1. Everything over 2, I will average that, right? So what do you get? We got 4.1 plus, I'm going to use a calculator here very quick, 17 divided by 4.1 equals 4.14, right? I will use the hundreds, 4.14, and I will divide this one by 2. What are we getting? Okay, plus 4.1 divided by 2. I'm getting 4.112, right? 4.12. And now we can move on with the next one, but you know, most likely, because I remember, if you guys remember this from yesterday's class, you will find out that, you know, the answer, the best approximation of this, if you want to go for the hundreds, will be 4.12 as the approximate value of what? Square root of 17. Okay? Any questions on this? Let's try, I don't know, 28. 28. Alright. Probably have to make it smaller. Good. I will use a different color here. Maybe green. Let me do some cleaning. Okay. Alright. We have to evaluate this expression here, right? And they're telling us that x equals -1. Alright, x equals -1, plug it in, right? I have square root of 2 times -1 plus 3 minus 10 times square root of -1 plus 1 minus 5 equals 1. Well, first of all, minus 1 plus 1 gives you a 0, so this whole term here will be 0, disappears, right? I have the other one, square root of -2 times 1, -2, right, plus 3 minus 5. This gives me what? Square root of 1 minus 5, and this will be 1 minus 5, which equals -4, and we're done. Make sense? Alright, one problem for today. Let's see, 29. The statement 1 plus 1/2 squared equals 1/2 minus 2, everything squared. Find and explain the error in the following proof. Let's see what's happening here. Well, obviously, the two statements are equal. First of all, this one is what? 1 plus 1/2 squared. That gives me 3/2, right? Everything squared, which equals to -3/2. Everything squared. And this are, you know, this is a true statement. Obviously, on the right side, if you square that negative number, will become positive, and you'll have 9/4 equals to 9/4, right? Now, what's happening here? Why this proof is not okay? Well, let's see. First of all, before they're squaring each one of the sides, they're just taking the square roots of them, and they're coming up with 1 plus 1/2 equals 1/2 minus 2. But remember, the definition of the square root of a number a is telling you to find the positive square root, right? Okay, that's by definition. You're looking for the principal square root of the number a, of your number a, and that's why here we cannot, you know, we cannot use 1/2 minus 2 as the square root of 1/2 minus 2, everything squared. First here you have to square it. You will come up with -3 halves, everything squared. Then you will, you know, I mean, basically first you subtract 2 from 1/2, right? And then you square everything, you get 9/4, and then you have to take the square root of 9/4, and you know, that will give you 3/2, because it has to be the positive square. So this is where the flaw is, right? You cannot take the square root of that before completing all the operations under the square root and basically coming up with the positive square root with the principal square root of whatever that value is, in this case 9/4. Okay, I hope it makes sense. We'll talk more in class today. Thank you.